Alright, here we go again. So, tangents to circles. Now we have three objectives here for this particular lesson. We'll be constructing tangents to a circle from a point away from that circle. Two, we'll be constructing internal or referred to as transversal tangents to two unequal circles. And finally, we'll be constructing external tangents to two unequal circles. Alright, so we're going to be starting with the first one, tangents to a circle at a point that is away from the circle. Alright, so here we are. Now with this one, we have a circle. Normally you will be given the diameter or the radius of the circle, and you'll be told where the point is away from the circle. So by definition, the tangent is basically a line which will be at 90 degrees to the radius of this circle. So if our radius of the circle, radius can be here or there or here or here or here, right? As long as the line is 90 degrees to the radius or the diameter of the circle, then that line is said to be a tangent, or the tangent to that particular circle. How do we establish this? Okay, so that we have the circle here. Of course, you'll be given the diameter, and we have the point. Now you'll be given the coordinates for the point, right? This point here is P. What we do is we are going to connect the center of the circle to the point P. Once we connect the center of the circle to the point P, then all we have to do now is find the midpoint of this line, find the midpoint of this line, and get a semicircle. So all we have to do is go to circle, and we look for the triangle. Once we see the triangle on the line, then we know that we have the midpoint. So let's go. What's going on? Alright, there we find it. So here is the triangle. So we know that that is the midpoint of the line. And we connect it to either point. Either we connect it to O or P. As long as that's the midpoint of the line, it will connect to O and P. Now, it's just three basic steps, right? Connect, semicircle, and then the tangent has been established. So from here, anywhere the semicircle cuts the circumference of the circle here or here, these are the tangent points. So if I connect from here to here, then this line, let me brighten it. So that line is said to be a tangent. So this line is a tangent to this particular circle. Alright, we'll do leader. So go to leader, and I will indicate that that line is a tangent. So this line there is a tangent. Alright? And it's as simple as that. Again, I'm saying that it could be from this point to P as well. So this line will also be a tangent from P to the circle. But we'll just stop it with this one. You just get the basic idea how to construct a tangent from a point away from the circle. Alright, let's move now to the second objective. So the second objective, we want to construct an internal or transversal tangent. So some books, some texts will use the term transversal. So an internal tangent is a tangent that runs between the two circles. So it either run this way or it can run that way. So we'd say it's an internal tangent, or we can say it's a transversal tangent. All right. Now, with that being said, we want to know how to go about doing that. The radius of this circle with center A is 30 mm, and the radius of this circle, center B, is 20 mm. Now, I want to introduce you over here to this pot. And I think that this pot will greatly assist you in always remembering when to add the radius and when to minus the radius. Now, if you notice that this arrow is saying if we should put something in a pot, if you're cooking and you put something in the pot, what are you doing? You're adding to the pot. So the sign there will be adding. If you're cooking and you're taking stuff out the pot, then it means that you will be subtracting from the pot. So the sign here will be minus. Now, why did I put this here? Since we want an internal tangent, internal, so that means that we're going to go in, then it means then that we are going to be adding. So the sign that we're going to be using is addition. So in this case now, we're going to add the radius of B plus the radius of A. When we add the radius of B plus the radius of A, we get 50. All right, just want you to understand that. Now let's look at the construction. So first thing we need to do is connect the centers. So we connect the center of the two circles, right? Upon connecting the center of the two circles, we are going to get the midpoint of the line that connects the two circles. So we go to circle and we get the midpoint. Once you see the triangle, you know that we get the midpoint. Now we can construct up here or we can construct down there, right? It doesn't really matter which one you want to use at this point in time for now. Now remember that we said that we'll add the radius. So we'll add the radius of this, which is 20 mm, and we're going to add the radius of this, which is 30 mm. So the total radius now would be 50 mm. So we're going to get a new circle. So a new circle at the bigger one, at the bigger circle, we're using the center of the bigger circle. So circle, I want R for radius, and then it will be 50. Now we get a new circle. Now this circle, anywhere this circle cuts this arc, anywhere the circle cut this arc, it could be here and it could be down there, because remember, as we said, we could have been constructing it down here as well. Now anywhere the circle cuts that arc, we're going to draw a line. So we're going to draw a line from A to where it cuts. All right, so we draw a line from A to where the circle cuts the semicircle, which is this one we want. All right, now we get a point. Now you see anywhere this line cut the outer circle, the given circle, then we're going to type point. So that now is where the tangent point will be. So any tangent we draw, it will touch right here at that point. Now we need to know where will the tangent point be on this circle here. What do? All we do is we click on this and copy it. So all we're doing is we're copying it. So we're going to move it and bring this to the center there. Now notice that this line cuts the little circle right here. So we're going to type point, and that now is where the tangent point is for that circle there. So what we do, we go to draw a line and we connect from here to there. And let me brighten this up because this is our tangent. And what type of tangent is it? It is our internal tangent, or we refer to as our transversal tangent. Alright, so that now is our tangent, or internal tangent, or refer to as our transversal tangent. Let me go to leader. Well, I'm gonna just copy this one. So we're copying that one and we put it there. Because what we're saying is that this is not is our tangent. But what type of tangent is it? It is our internal. It is our internal tangent. Alright? So that is how we get our internal tangent. Alright? So you see, we're moving quite along. We're going on. We're going on. Let's move now to objective number 3. And with objective number 3, we are supposed to construct an external tangent to two unequal circles. All right, so this says to two unequal circles. Let's edit this. All right, so just backspace that and we edit that. Okay, good. So external tangents to two unequal circles. So here we have circle center A of radius 20 millimeters and circle with center A of 40 millimeters and circle with center B of 20 millimeters. All right. Now let's look at the pot again. Now external tangent means it's outside. So if we're taking something out of the pot, then we are going to use the sign, the minus. All right. So what the external tangent would be, it would be a line that will be running on the outside of the circle, whether here, so it is running on the outside of the circle and it is common to both circles, right? Or it can be running this side, but it is still on the outside of the circle and it is common to both. All right, so these tangents are also known as common tangents. It's common because it's touching both circles. So it can be a common, so it can be a common internal or common external. All right, so how we approach it again? We would do what now? Minus. Because since we are taking out of the pot, we're taking out of the pot because it's going to be an outside or external tangent. So we're going to minus 20 from 40, and in this case we have radius 20. But what do we do initially? We connect the centers. So we go ahead, we connect the centers. After connecting the centers, we establish the midpoint. And once we establish a midpoint, we get our semicircle, or in this case a circle. But I keep saying semicircle because by right I would probably trim the bottom part here. But I want you to want to show you that the tangent can be on this side or on that side. It doesn't really matter. It just depends on what problem you got to solve. All right. Now in this case now we're minusing B from A. So we'd end up with 20. So we'll go to circle, center, and its radius. So we type R, enter, 20. So that now is our radius. Now remember, anytime you get this circle, anywhere this circle cuts the midpoint circle, which is this one, right? So in this case, let me type point, P-O-I. Not type point. Let me connect from here through to this point. So anywhere the circle cuts the midpoint circle right here. So we're going to extend this EX. Now we're going to put the point right here because this now is telling you that the tangent point will be at this exact spot on the outside circle. So we type point and we drop the point right there. Right? Now time for us to get where on this circle will the tangent point be. All we do is click on this and we copy. So I'm going to copy from here and bring it to the center there. All right. Now point again, and we know that the tangent point will be right there. So all we need to do is connect from here to there, and that will be our tangent. Let's brighten this up. Outline. All right, and again, let me copy this, and that will be our tangent. All right, but this will be external, ex. So this is our external tangent. Let me drag this a little bit further out, like that. All right. So this now would be our external tangent. Now remember we said initially that the tangent must be at 90 degrees to any radius or diameter. Therefore, in this case, if this here is our radius or diameter, this would refer to, we can refer to this also in a geometric term as the normal, right? Similarly, this would also be referred to as the normal. So we have a normal and a tangent. The relationship between a normal and a tangent is that they are perpendicular. They are 90 degrees to each other. So let's check to see if we have 90. So we'll go to dimension, we'll type A, enter, and we'll check between this angle and this angle. And you notice that we get 90 degrees. Good. So that's how we know that this is accurate and it is our or the required um, external tangent. All right. So we have looked at the circle, a tangent connecting a circle from a given point away from the circle. We also constructed the internal or transversal tangent to two unequal circles, and we have now also constructed the external tangent to two unequal circles. We also learned the relationship in terms of how do we know when to add and how do we know when to minus in terms of the radius. Or when do we add the radius? When do we minus the radius? We now understand why. All right. Thank you for this one. Again, like, share, and subscribe.